Okay, on this one, we're asked to find the trigonometric ratios. So there are 6 of them. We've got sine, cosine, tangent, cosecant, which is provided, secant, and cotangent. All right, now this one, I'm looking at this and I'm going, ooh, okay, I'm a little worried here because on a normal ratio, I'm used to fractions. This one doesn't have a fraction, but don't be dismayed. This one's not too bad. On all of these, first thing we need to do is identify what is cosecant. And cosecant is really the opposite divided by, the hypotenuse divided by the opposite. Okay, so if I draw a picture, it really seems to help. So I'm going to draw a picture of the triangle. Okay, and it doesn't have to be matching perfectly, but it'll just give you an idea. Here's theta. Okay, now I need cosecant is the opposite, hypotenuse divided by the opposite. So hypotenuse on this side divided by the opposite side, which is up here. Okay, this is the adjacent side, opposite, and hypotenuse. So I know it's radical 10, but I don't have anything on bottom, which means this is the same thing. If I were to write this as a fraction, it would be the square root of 10 over 1. So let's do that. Okay, so the hypotenuse would be the square root of 10. That means this top opposite angle would be 1. Okay, so now that we have that, all right, that's not so bad. Now we can go through and use Pythagorean's theorem to find this other side. In order to fill out all my ratios, I need to have all sides of the triangle. So I'm going to use Pythagorean's theorem to find this missing side right here. Okay, Pythagorean's theorem is a squared plus b squared equals c squared. And c squared is always your hypotenuse. Okay, so c is your hypotenuse. A and b are these two, and they can be written in any order because it's an addition sign. So, all right, so let's kind of fill in what we know. I'm looking for a squared, so I've got 1 squared, which is 1. Square root of 10 squared, well, square root of 10 times square root of 10 is square root of 100, which is 10. So that makes it kind of nice. So then I'm going to get rid of this 1. I'm going to subtract both sides by 1. I end up with a squared equals 9, which means a equals 3. And this is a positive 3 because it's a measurement. Normally a could either equal positive or negative 3, but because it's a measurement, it will only be a positive 3, right? I mean, we don't say it's negative 3 inches. That's weird. So, okay, now that we have our 3 in there, I'm going to write it in. Okay, now that we have our triangle drawn, we can go through each one of these ratios. All right, the first one is sine, which is the opposite side divided by the hypotenuse. Okay, so here's my opposite side divided by my hypotenuse. So 1 divided by square root of 10. This is all great, but we can't have a radical on the bottom. We have to, what we call, rationalize the denominator, right? This is an irrational number. We need to make it a rational one. The way we do that is we multiply top and bottom by the square root of 10. Now, in doing so, we haven't changed the value, right? The square root of 10 divided by square root of 10 is just 1. And when we multiply something by 1, we're not changing the value at all. All right, but look at what happens when we do this. 1 times the square root of 10 is just the square root of 10. And on bottom, we have square root of 10 times square root of 10, which is square root of 100, which is 10. Okay, so this is my sine, square root of 10 over 10. Cosine is going to be the adjacent side, right? The one right next to it, adjacent side divided by the hypotenuse. So 3 divided by square root of 10. Now, we've gone through this before, but the square root of 10, we can't have that on the bottom. So we got to multiply top and bottom by square root of 10. This will give me 3 square root of 10 on top and then 10 on the bottom. For our tangent, this one is not so bad. This is the opposite side, so the opposite of this theta is 1 divided by the adjacent side. So 1 over 3, which is 1/3. That one's a piece of cake. That's nice. All right, now, cosecant is the hypotenuse divided by the opposite. What cosecant really is, it is the reciprocal of this one. Or, as I like to refer to it, the refliprical, right? All we're going to do is flip these two. Well, this is 1 over square root of 10, so that would end up being square root of 10 over 1, which is, if we reduce that down, is just the square root of 10. Now, this is a key one because if we've done this correctly, this was the one that was provided, so those two ought to match. And it does, so we're okay. On the next one, we're going to go to the secant, which is really the reciprocal of this one. So instead of 3 over square root of 10, I'm going to go square root of 10 over 3. And that's it. That's as far as you need to go with it. And then the cotangent, same thing. We're going to do the reciprocal, which instead of 1/3, it'll be 3 over 1. And 3 over 1 can be reduced. 3 over 1 is just 3. All right, so these are all of your answers on this one. You want to check this. It's a little bit of a process. First, I draw the triangle. Then I use Pythagorean's theorem to find the missing side. And then I can plug in my ratios. Make sure that you don't have any square roots on the bottom, right? We have to rationalize that denominator. And here are your answers.